So these are some of the ways in which we use AI and data science in the Awake platform. And so I'm going to go through and just kind of explain each of these segments one by one here. So first, and really most important, if we're talking about applications of AI or data science to the network, this is most critical, okay? This kind of came up a little bit earlier, right? We see very, very successful applications of AI on the endpoint in EDR type technologies, and it's tempting to think that we could use those same approaches on the network, and it turns out that that is absolutely and utterly false. That data on endpoints tends to be incredibly structured. You know, if we're talking about analyzing an executable to figure out if it's malware or not, executables are very, very highly structured, very rigid and strict requirements about what type of data is allowed in what segments of that file. On the network, we don't have that at all. We have protocols. The software developers don't even need to adhere to the specifications in the RFCs. They can use the protocol for what it was intended for or not. We have companies constantly creating their own proprietary custom protocols and putting those on the network. And so we don't have the same structure to the data that we're analyzing on the network that we do on the endpoint. And that's why this is very subtle. But you may notice I don't really talk about AI models doing, you know, complete threat detection on the network, and we do hear that in the industry a lot. Hey, look at this AI and it detects the threats. And you know, if you do see those conversations, you see people talking about that should really throw up some red flags for you. Instead, AI is much more successful in the network when used in combination with either other types of AI or other types of data science or other techniques, and we're going to explore that here. So first and foremost, we need to take this, you know, totally unstructured data and convert it into a more normalized form. And the way we do that at Awake is we convert traffic ultimately into people and devices. And so you'll see screens like this in the system. And what this is showing us is that there's this particular device that we're looking at here. And this is a very, very common view that we see when using the system. And we see that this device has been on these IP addresses for, you know, in this case, a couple hours. We see some of these go up to, you know, maybe a couple days. Actually, further down, there's some that are like 20 minutes at a time. And so this device has been tracked, and we'll go highlight over here, you know, it's almost 9 months we've been tracking this device that, you know, uses IPs for a few hours at a time and, you know, comes and goes and moves around the network, which is incredibly, incredibly common for devices in most enterprise networks. Now, this is so important because what we're going to ultimately be talking about is analyzing devices and behaviors. And if AI is going to do that, it needs to be able to understand, well, what's normal and what's abnormal for a given device or a set of devices. But if you haven't solved this problem that we're looking at right here, well, then the AI would be analyzing a device for 3 hours at a time, and that's it, right? And so this is a really, really critical, like pretty much every network analytics technology you can think of would see in the 100 IP address that make up this device, they would see 100 different devices. But now this is one device with 100 different IP addresses over the course of almost 9 months here. And so this is step number one, prerequisite. You have to solve this problem before you can do any more accurate or interesting analytics that are capable of detecting more than signatures could detect, you know, up to 20 years ago. Okay, so once we've normalized the data and we now have people and devices, we start to aggregate those sessions into activities and start identifying uncommon artifacts, right? So we look across all the traffic, and for this particular device, what we see an example of is the system has determined it's notable, it's interesting. These artifacts are uncommon and interesting relative to all the other devices in the network. And this device is, you know, going to these servers, you know, using TLS traffic, and we also see this user agent in HTTP traffic. And if you look this up, it turns out that yes, this is indeed related to malware. But this is just the first step. Kind of identify these fingerprints of devices and identify what in the fingerprints separate those devices from others. Now, once the AI has identified what are potentially interesting artifacts, well, then it starts looking to see how those artifacts are used in behaviors from that device. So here's an example of another device, and we see over there on the right-hand side some of those fingerprints that have been put together and have helped to identify this device that's going to this uncommon network using an uncommon TLS fingerprint. And what we see up at the top there is this beautiful once every 24 hours or so pattern, once per day beaconing that has actually ultimately triggered some other models, and we will be talking about models like this in a moment. One thing I want to point out here, just really quick, because we're not going to get into this anywhere else in this presentation, but it's very, very cool. Awake, we put literally years into developing a domain-specific language, a DSL, that allows the users of our system to come in and not only look at the models that we're talking about throughout this entire presentation, but come in and edit them, change them, create your own. It's an open language. There's nothing like it that we've seen out there in the security industry or others yet, to be honest. But it's an open language that allows you to come in and in terms that analysts and threat researchers understand, develop basically data science models and ask the system to take the characteristics that we're looking for and apply those to models at lower levels in the system. So it's very, very, very neat capability there. Okay, so those are, we kind of talked about, and I'll show you this again when we pivot over to the demo, but those are models that ultimately identify potentially threatening activities, but then there's also investigation. This is where things get really neat, and this is what we're going to focus on mostly in the hands-on demo. But let me, before we get to that, just one last little exercise here to kind of get you thinking about the AI application to investigation. So you get an alert for this domain, and we have the question up here. Well, what do you think? Is it good or bad? Well, not enough information here, right? You need to do some more investigation. You have an alert, but is it a false positive, right? Is it real? You need to figure that out, and that's what analysts do all day long in organizations with the alerts they get. So if you take this domain and you go search, all of the reputation databases out there, you see that there's no detections for it. It's clean in all the databases. In fact, you go to a number of other sites, you'll find that not only is this domain considered clean kind of across the board, but like we see here, this is telling us this domain is top 10,000 domains on the internet, which would make it incredibly common if true. And in fact, when we go look at the reputation databases of some very large companies out there, one of the largest or most common next-gen firewall companies out there, which of course next-gen firewalls utilize domain reputation, and we look at the reputation of this domain across those types of systems. What we see is that they all come back and say no problem. This domain, this is a lot like Google or Schwab or Amazon.com. So, the more you search, the more it looks okay. So what do you think? You're probably thinking, oh, this is probably okay. And if you did get an alert for this, it's probably a false positive. Even going into virus total, we see, one hit out of 82 engines considered this domain to be a problem. And usually when you see 1 out of 82, that's an indication of a false positive. Except you may notice over there on the right-hand side, the icon for this domain is Google's logo, which is interesting. I guess this could potentially be a Google domain, although I would probably guess not. And so speaking of Google, if we do a search for this domain, here's what we find. Now, as a human being looking at this information right here, what do you think? Do you think this is good, or do you think if you had an alert for this domain and you did this search and you found these results, would you think this is a false positive or true positive? Well, I think, most people at this point would, if you were thinking false positive before, change your mind and switch to true positive. This is probably something bad. And that's easy for us to do as human beings, right? Now think about this from an automation perspective. If you had a system that is taking artifacts, like say a domain, from alerts and going and checking, reference sources like reputation databases and VirusTotal and all these other places, and everything comes back clean, what is that automation going to determine? It's going to determine it's clean, right? So this is actually a very sophisticated problem for automation to solve, but AI can actually solve it pretty elegantly. And so what I'm going to show you really quickly, and this is, I think, one of the last things we're going to see here, I'm going to switch to demo, but I'm going to show you some system internal. So you're getting ready to see some JSON kind of formatted data, but this is the under the hood stuff. And that question is, what does Ava, which is our AI-based investigative assistant, our virtual assistant here, what does Ava think about that domain? And Ava does a number of things, including searching VirusTotal and all those other sources just to see, hey, is it known bad? But if it's not known bad, that doesn't mean it's no good. So Ava does some further digging, and what you see here is Ava has gone out and done an internet search, just like we did as humans, where we searched Google and we looked at the results that came back. But Ava not only looks at those summaries that we only looked at in that previous slide. Ava goes to those pages and reads the content and tries to understand what are all these, if I can find pages out there that talk about this artifact I'm searching for, what are they saying about it? What kind of things are they talking about? And what this is showing here is that Ava has determined, this artifact, yes, indeed, it has been found out on the internet. And the things that the internet is saying about it, even though Ava wasn't configured to go look at websites like malwarefixes.com or things like that, Ava found that in the search and then understood through topic modeling and other techniques that no, this probably is bad. So Ava does indeed think that this domain is suspicious or bad. So kind of a neat little example there. Let's go ahead and pivot over and see a more end-to-end, workflow, kind of utilizing a lot of these techniques that we were just talking about. So we're over here. We're looking at a situation, and a situation is one of the highest levels of kind of abstract reporting in the system. So Awake is ultimately a full packet capture system. We record all the traffic, and it's just layers upon layers of analytics and AI and data science and other techniques right on top of that, which is ultimately what you're going to see here. But the reality is you should not really ever need to get down into the packet data. But we will. We'll show that here. But so what do we see here, right? Well, we see in this situation, right? It's titled "Large Download via Cobalt Strike." So that's the ultimate model that triggered, that initiated the investigation. And so in the investigation, what was found that this system, it looks like this may have been phishing related because the system was not doing web surfing. It was only interacting with email at the time, and immediately after that, the system interacts with this domain, jQuery351minjs.com. So you may very commonly see jQuery in network traffic. However, this domain is not, there's no official jQuery domain that's based on a particular version of jQuery. So, funny little trick there. And then finally, we see the download from this IP address where the download occurred from. And so over here on the map, right, it's telling us Office 365 is related to this because it looks like this was phishing related. However, it's not red, so this is an acceptable use, but is related to this particular incident. Then the system interacted with this jQuery domain, very likely the first stage, and then second stage, larger download came from this IP address that didn't have a domain. Now, here's the thing that is pretty incredible about this. A human did not do this investigation. So we come over here, we'll look at the supporting artifacts, right? We see almost every single one of these, a human clicked on the alert and said, hit initiate the investigation. And we are actually now working on fully automated, no human involvement whatsoever. But human initiated, and Ava the AI did the rest of the analysis from here, which is what we see in this icon, these icons. And so this is pretty interesting, right? The domains, possible command and control, office365.com, it determines is legitimate. We see that we have AVA analysis of both the IP address, which it has labeled possibly an unknown threat. We also have AVA analysis for this jQuery, also possibly unknown threat. And what's really interesting is when we get into, let's go into the audit log here. Normally we don't do analysis at this level, but when we go through the audit log, what we see is the enormous amount of work being done behind the scenes. And it's worth noting that this domain right here, it was ultimately identified because it was first visited, this device first went to this domain for the very, very first time just before this. Now, that happens a lot, actually, when you get suspicious kind of events and you ask that question, hey, what has this device done for the first time just before it? Devices are always, especially if you have users on it, and they're surfing the internet, they're always doing new things for the first time, many, many, many times a day. But Ava went further and did that analysis of this domain and ultimately determined that no, this doesn't. It wasn't just the first time. I actually think that this is all malicious and all related. So completely automated investigation there, but driven not by automation, which again we were kind of thinking about that. How does automation tell if something's bad? Instead. A much sort of deeper analysis there. So let's pivot over here and kind of go a little deeper into the system. So this was the system that we were looking at a moment ago. We were looking at the system details page now, or what we call entity IQ, device profile. And this is an aggregation of the analysis of this device actually now over the past 68 weeks since it was first seen. And so we see this particular device has only had one IP address, so very easy to track. But we got some models that have triggered more recently, and we can pivot down into these and ultimately get into the traffic, right? Because as I mentioned, Awake, we are a full packet capture system. We record all the traffic, but the truth is you should very rarely, almost never need to get down into the traffic because the automation should be taking care of everything for you. Now I triggered, I clicked on one of those models that triggered the spoofed HTTP to AVA analyze destination. So this is kind of cool. So we're looking at a threat detection model now, an individual model, as opposed to that AI-driven investigation. And that model triggered because it says this HTTP is spoofed. And again, full packet capture, but we'll come over here and kind of look at the parse data. And when we show traffic like this to humans, in fact, a lot of times investigators will see this and kind of think, well, wait a minute, this is a false positive, right? This is not spoof. This is normal. This is okay traffic. In fact, if I take this out, we can run this through user agent parser. I mean, this doesn't seem like there's any problems here. In fact, there is. So the model has determined that, well, yeah, this might be a valid user agent, but it is not valid in the context of this device. This device should not be sent. This is spoofed. In combination with that, Ava has done an analysis of this domain. And when you put those things together, this spoofed header going to this particular destination, and actually, so we got this up here. So what did Ava determine? Again, we're looking under the hood, right? So this is kind of behind the scenes what Ava was thinking about. This hard domain name.biz has labeled it possibly an unknown threat. Why did it say unknown threat? Actually, we saw that earlier, right? By the way, it's worth noting that in all the categorization engines that VirusTotal uses, which is somewhere around 9 of them or so, it's totally uncategorized. But there are some hits in VirusTotal. Right, so we do see some malware, and I think we can control click here, right? Bring this up, and we see what kind of malware comes up here. It is, it's okay, it's malware. It's bad stuff. Going back in here, so we have a few samples of malware that communicate with that domain. Ava has also identified these websites additionally that discuss this domain that Ava has found particularly interesting. But also there are very, very, very few results out there. So that kind of helps illustrate some of the reasons, some of the thinking behind Ava's assessment here that's possibly unknown. Very, very, very little about this known on the internet, although there is indication that it is risk related. So I can come back over here, right? And so we put this all together. Basically, I wanted to try to very quickly show a demo showing how AI can be used to do both things that top tier human analysts can do, like make investigative judgments in the face of conflicting information. As we saw when looking up domain reputation information, right? Ava can look and see that, yes, hundreds of other vendors and data sources out there think it's safe, but Ava can make its own decisions to the contrary and decide, no, actually, in the context I see this, I don't think it's safe. But AI can also be used to do things that humans just cannot do, like tracking and clustering and comparing devices over, not just minutes or hours or days, but months and years. Actually, is an example that we saw just a moment ago. And I didn't mention it earlier, but think about this, right? Think about what that AI is doing. Every packet that comes across the wire, every packet it takes up, it has to make a decision. And that decision is, does this traffic I'm looking at belong to the device that had this IP address a minute ago, or an hour ago, or a day, or a week ago? Or does this traffic belong to a new device? And if it's a new device, is this a device that was somewhere else in the network that has now moved over and is on this IP address now? Or is this device completely new to the network that's never been seen before, right? So, that is a job that a human analyst could do probably for a single device with about a week's worth of work, and we know this because we used to have to do this in the past, but it's not something that humans can do across tens of thousands of devices and over this amount of time. And again, by doing that, by leveraging AI for tasks like this, we can enable, without necessarily requiring AI to do more sophisticated detection, that alone just enables far more sophisticated and accurate detection to take place. Thank you for the time.